नहीं, स्टक एट 0। ए का एक्चुअल वैल्यू इज 1, सो फॉल्ट कब होगा? जब वो 0 पर स्टक होगा। तो इसका
ओके
फॉल्ट
मैम।
लिस्ट क्या होगा? ए स्टक एट 0। ठीक है। ऐसे ही फॉल्ट लिस्ट ऑफ बी। बी पर क्या फॉल्ट हो सकता है कि ये 0 हो जाए? सो दिस इज बी स्टक एट 0। फॉल्ट लिस्ट ऑफ सी। C की actual value is 1. So if this is stuck at 0, then I can have a fault. The other possible fault is अगर B is stuck at 0, because B अगर stuck at 0 हो गया, then at C it may be propagated, right? Hence this contains B0 as well. So LC will have C0 and B0. Similarly, LD, fault list for line D. फॉल्ट लिस्ट फॉर लाइन डी क्या हो सकता है? डी का एक्चुअल वैल्यू इज 1, लेकिन ये 0 पे अगर स्टक हो गया देन इट इज एन एरर, सो डी 0. ऑल्सो इफ आई गो बैक टू माई प्राइमरी इनपुट, if b is stuck at 0, this can also be propagated at d. Therefore I get an additional fault in the list, that is b0. ठीक. Now look
यस
at
मैम।
e. E की actual value is 1. It will be at fault if the value is 0. So the first possibility is E stuck at 0. What are the other cases when E can get to 0? This is an AND gate. Actual value of both the inputs is 1, 1. If either of the value at the input goes to 0, तो E का value अपने आप 0 हो जाएगा. It means what? Either A is 0
बी
or
0।
B नहीं, C. या तो A 0 हो गया या C 0 हो गया. अभी हम B की बात नहीं कर रहे हैं. Either A is 0 or C is 0. ठीक है. इसके
यस।
अलावा B भी अगर 0 हो गया, then it will be propagated to C. So B stuck at 0 और A stuck at 0, दोनों में से एक भी अगर हो जाए, then also there will be a problem. ठीक है. सो और के लिए हम क्या करते हैं? यूनियन करते हैं. और means union. So what will LE have? The fault list of E contains E naught, A naught union C naught. Yani A naught, sorry, the fault list at A, I should not write L here. It should be LA or LC. The fault which exists at A or at C. Similarly, fault which exists at A or fault that exists at B. So what is LA union LC? A0, B0, C0. So I add this A0, B0, C0. Then LA union LB, which is A0 and B0, which already is written in my fault list. So I need not write it again. So the fault list LE consists of 4 faults: A0, B0, C0 and E0. Similarly, fault list for F. F की actual value is 0 if this value gets stuck at 1. So I have F1 in my fault list. Also, this will be faulty 1 if D is at fault. So I should have the fault list of D. Fault list of D क्या है? B0 and D0. So my total fault list becomes F1, B0, D0. Lastly, for LG, G का actual value is 1. So if it is stuck at 0, this becomes a fault. So G0. G0 0 कब होगा? जब इस OR गेट के दोनों इनपुट 0 हो जाए. Right? वो कब होगा? When E is at fault, it means there is a fault in the fault list E, but not in F. LE में है, लेकिन LF में नहीं है, और I can say LE minus LF. E पर fault है लेकिन F पर नहीं है, so that this becomes 0, this is already 0. ठीक? So what will be LE minus LF? LE ये रहा, LF ये रहा, इनमें से माइनस कर दो जो भी कॉमन है, that we will remove, which is B naught. So I'll remove B naught from LE. So my fault list for G becomes G naught as it is. LE में से E naught आ जाएगा, A naught आ जाएगा. B naught will not come because LE minus LF. B naught is common, so I will eliminate it. Then I will have C naught. So LG, the fault list of G contains 4 faults: G naught, E naught, A naught, and C naught. So using the test vector 1, 1, the possible faults that can be detected are these: stuck at 0 fault at wire A, C, E, and G. ठीक है?
Yes, ma'am.
Okay. Now let us move to the last type of uh, simulation, that is concurrent simulation. Concurrent simulation is slightly above your deductive fault simulation and somewhat similar to it again, because here also we consider all the faults together. As your deductive fault simulation, सारे faults एक ही pass में हम simulate कर लेते हैं. We simulate the non-faulty as well as all faulty circuits in one pass, that is concurrently, right? This fault simulation also works in event mode. Event mode हमने क्या कहा था कि if this is a wire to any gate and there exists an event 1 से 0 change हो रहा है, then we will consider this wire only. We will not consider this wire in the next pass. जब test vector change हो रहा है, जैसे initially 1 1 है और केवल यहीं पर bit change हो रही है so that the vector becomes 0 1. So we are only analyzing this line and we do not look into this line. This is what we did. We did not update the fault list for this wire in the next pass. So this is called event mode. जहां पर event होगा 1 से 0 या 0 से 1 change हो रहा होगा, only those points we need to consider. But what are the difference between your concurrent and the previous fault simulation, that is deductive fault simulation? Deductive fault simulation में हमने list of fault at wires calculate किया था. ठीक है? We were talking of individual wire for deductive fault simulation. Abhi for concurrent fault simulation, we will consider each element. It means we will consider the fault at this gate, नॉट इंडिविजुअल वायर. तो पहले जहां हम दो लाइंस के लिए एनालिसिस कर रहे थे, दो फॉल्ट लिस्ट निकाल रहे थे, अभी कॉन्करेंट फॉल्ट सिमुलेशन में वी विल कंसिडर इट एज ओनली वन गेट. ठीक है? सो वी आर यू वर्किंग फॉर ईच एलिमेंट एंड नॉट द लाइंस इन कॉन्करेंट फॉल्ट सिमुलेशन. Another difference between deductive and concurrent fault simulation is that when we were writing the fault list for these wires, we were only considering the value at those wires. So my fault contained only the information about the faulty value at that particular wire. Whereas in the concurrent fault simulation, my fault is quite elaborative. So more memory will be required to store this fault, but the uh, amount of memory space that it requires will be reduced due to the number of elements used now instead of wires. So when we talk about the fault being written, the fault is mentioned along with the value of inputs and corresponding output for the logic gate. हर फॉल्ट के लिए उसके इनपुट क्या होगा और आउटपुट क्या होगा, दिस इज स्टोर्ड इन डेटा। ठीक है। However, this runs faster than deductive fault simulation. ज्यादा डेटा स्टोर कर रहे हैं हम फॉल्ट इंफॉर्मेशन में, लेकिन फिर भी ये डिडक्टिव सिमुलेशन से फास्टर है। So first we look into how do we write the fault list for my concurrent fault simulation. When I say concurrent fault simulation कर रहे हैं, तो इसका मतलब मेरे पास एक नॉन फॉल्टी सर्किट होना चाहिए और उसके साथ ऑल पॉसिबल फॉल्टी सर्किट्स होने चाहिए, right? Let us say we have a two input AND gate and the actual inputs to this AND gate are 0 and 1. A equal to 0, B equal to 1. If this is the input, the output of this AND gate should be 0. So this we call as good gate. Without any fault, एक गेट सिमुलेट हुआ है जिसका इनपुट इज 0 1 एंड आउटपुट इज 0, वी कॉल इट गुड गेट। इसके अलावा साइमल्टेनियसली वी विल ट्राई टू हैव ऑल द पॉसिबल फॉल्ट्स इन द फॉर्म ऑफ बैड गेट्स। क्या क्या फॉल्ट हो सकती है? पहला फॉल्ट हो सकता है a is stuck at 1, actual value is 0 but it gets stuck at 1. If a is stuck at 1, what are the inputs to my logic gate now? A became 1, B is already 1, so inputs are 1 1. And if the inputs are 1 1, my output will be equal to 1 for the AND gate. So this is the fault that is inside the first fault that will be considered. Okay. Next, what is the fault that can be considered? Another input is B, jiska actual value is 1. So another possible fault is B may stuck at 0. So if the fault is B stuck at 0, what is the input to the gate now? 0 0. क्योंकि A तो सही में 0 है, B faulty 0 है, and in this case of input 0 0, the output will be 0 for my AND gate. And third case, my output out is stuck at 1. अगर output stuck at 1 है, तो what are the inputs? Still 0 1, but instead of getting a value 0, output is given as 1. So for one good gate, I have 3 bad gates considered. You may write the fault list in this way, or in book, it is mentioned in the form of 3 more and symbols, where inside this and symbol at the center, we write the fault, that is A1. For this A1 fault, the input is 1 1 and the output is 1. Right? I can write the fault like this. The second is B naught. B is stuck at 0, so that the inputs become 0 0 and the output becomes 0. And the third possible fault is out stuck at 1, so that the input is 0 1 and the output is 1. You can use either of the two representations to represent the fault list for the concurrent fault simulation. हर लॉजिक गेट के लिए हम ऐसे ही गुड गेट और बैड गेट्स आइडेंटिफाई करेंगे. Is it clear how to identify the bad gates? Should we move with an example?
Yes, ma'am.
Okay. We take the last circuit again. Here. Now, डिडक्टिव फॉल्ट सिमुलेशन जब हमने किया था तो हमने कितने सारे फॉल्ट लिस्ट बनाए थे? LA, LB, LC, LD, LE, LF and LG. But for concurrent fault simulation, we will have only 3 elements analyzed. One is this AND gate, the other is this NOT gate, and the third is this OR gate. So let us begin. The numbers that are written right now, logic values 1, 1, 1, 1, and 0, these are non-faulty outputs. And correspondingly, within the gates, the value for non-faulty circuits are written. For an AND gate, the actual inputs are 1 1 and the output is 1. For the NOT gate, actual input is 1 and the output is 0. For the OR gate, actual inputs are 1 and 0 and the output is 1. So these are good gates. Now we start making the library, or we start making the fault list for each of these. Let us start with this AND gate. What are the possible faults that this AND gate can see? Anyone? Any first fault?
A stuck at 0.
A stuck at 0. Okay. And if we simulate A stuck at 0 or consider A stuck at 0, what will be the inputs to this AND gate?
0, 1.
0 and 1. Okay. And for the input 0, 1, the output will be 0.
0.
Another possible fault?
C stuck at 0.
C stuck at 0. So input बन जाएगा 1 0, output will be 0. The other stuck at fault?
E stuck at
D
0.
stuck at 0.
E stuck at 0. तो input तो original रहेगा 1 1, output becomes 0. Any other possible fault?
'मैम दोनों स्टक एट 0 नहीं कर सकते?
नहीं, सिंगल stuck at fault होती है ना, हमने पहले ही कहा.
यस मैम. मैम
But
B
we,
at 0.
yes, B stuck at 0. हमेशा लॉजिक गेट के लोकल इनपुट्स एंड आउटपुट्स के बाद we try to move towards primary inputs. So A and C are the local inputs to this AND gate. E is the local output. Now extend towards primary input. C का input कहाँ से आ रहा है? B से. So I should consider the stuck at fault B0 also. अगर B equal to 0 हो गया तो input क्या बनेगा इस AND gate का?
1 0.
1 0. And correspondingly output is 0. So for the first test vector 1 1, I will have these 4 bad gates in my list for this AND gate. अब इस NOT gate के bad gates बताओ. What are the possibilities of faults here?
D stuck at 0.
D stuck at 0, fine. D stuck at 0 होगा तो input is 0 and the output is 1. और
B stuck at 0.
B stuck at 0. पहले local वाले पूरे कर लेते हैं.
Okay.
Output is F stuck at 1. तो input तो correct 1 है but output is also 1. And the third will be my primary input which is B stuck at 0. B stuck at 0 है तो input 0 हो गया, output 1 हो गया. Fine. Now for this OR gate. OR gate के बताओ faults. एक तो E पे रहेगा, E stuck at 0. एक प्राइमरी इनपुट F है तो F stuck at 1. Primary output is G stuck at 0. If E is stuck at 0, the inputs become 0 0 and correspondingly output becomes 0. F1, F stuck at 1, so E to 1 rahega. F also becomes 1, so G remains 1. G stuck at 0 means E ki actual value 1, 0 for F and G becomes 0. ये तो हो गए मेरे primary wires. Now extend back to your primary inputs. ये local wires हो गए, अभी primary inputs की तरफ जाओ. E की fault कब आ सकती है? Due to the fault in this AND gate as well. So E stuck at 0 can happen when there is a fault at this AND gate. What possible fault will put E equal to 0?
A stuck at 0 or C stuck at 0.
A stuck at 0 or C stuck at 0. Also B may be stuck at 0. So I say A stuck at 0. B stuck at 0 and C stuck at 0. A stuck at 0, B stuck at 0 and C stuck at this is C stuck at 0. A stuck at 0 है तो इनपुट क्या बनेगा 0 1 and the output will be 0. B stuck at 0 है तो इनपुट बनेगा ओह सॉरी A इक्वल टू 0 है तो इसका इनपुट क्या बनेगा A equal to 0 तो input of AND gate is 0 1 so the output here is 0 which becomes input here 0 so ये तो 0 हो गया and B as it is 1 जिसकी वजह से F is 0 so the input of this OR gate is 0. So the input of the OR gate for faulty A naught is 0 0. Output is 0. B equal to 0 पर input क्या बनेगा इस OR gate का A 1 है B 0 हो गया B 0 होते ही C भी 0 हो गया so the input of the AND gate is 1 0 so the output will be 0 so this input of the OR gate will go to 0. What about the next input of the OR gate B equal to 0 which is D equal to 0 so F equal to 1 so the other input of the AND gate OR gate becomes 1 so the output should be 1. Fine. C naught के लिए C0 होते ही E0 हो गया so the first input to the OR gate becomes 0 and the other input remains as it is because the fault on C is not reflected on D so the actual value still exists so 0 0 के लिए output is 0. ठीक है इतने में कोई दिक्कत ये तो हम यहां से पीछे प्राइमरी इनपुट्स पर चले गए फ्रॉम E वायर नाउ लुक एट दिस F. This possible fault F1 may be due to this faulty NOT gate as well, which means fault at D or fault at B. So when I move towards primary input through this wire, I add another fault which may exist, which is D stuck at 1. 1 or 0? 0. D की actual value is 1, so D stuck at 0. What will be the input of the OR gate if D is stuck at 0? E का value तो as it is. D becomes 0 तो F equal to 1 हो गया. So the input of this OR gate is 1. So 1 1 1 1 के लिए output should be 1. This is my first pass of concurrent fault simulation. So using test vector 1 1 my circuit is able to detect these 7 faults. E naught, F1, G naught, A naught, B naught, C naught and D naught. And in addition to this list, I have a list of bad gates for the AND gate and a list of bad gates for NOT gate. Okay. Now let us take the next step. Next step may we assume that the test vector becomes 0 1. So there exists an event on line A, a forced event, and the input changes from 1 to 0. If this input changes from 1 to 0, I expect that the good gate changes to input 0 1 so that the output is also changed to 0. So अब मेरा good gate simulation क्या हो गया? Input should be 0 1 and output should be 0. If I continue this transition at E will cause a transition here from 1 say 0. And if this transition occurs here, 0 0 becomes the input to the OR gate, the output goes to 0. So there is a change at output of this OR gate. तब concurrent fault simulation क्या करेगा? केवल इस AND gate और इस OR gate को update करेगा. It will not consider any updation in this step for this NOT gate because no event occurs at the NOT gate. तो इस list को तो वो as it is छोड़ देगा. It will preserve this list. It will not change anything here, but it will start working for changes or the updation in the fault list of AND gate and OR gate. The first thing is that it will eliminate the bad gates which are now good. Good कैसे है? अगर उनका input 0 1 और output 0 है. So all the inputs and outputs are matching. For example here A naught जो हमारा गेट था इसका इनपुट 0 1 है और आउटपुट इज 0 which is same as now a good gate. Therefore my concurrent simulation will eliminate this as a bad gate, that this is no more a bad gate. ठीक है? If there is a change 1 to 0 at input here, here also the change will be reflected. Here also change will be reflected. Here also the change will be reflected. If I look at this C naught, the inputs become 0 0 and the output is 0. So this will still be considered as a bad gate because at least one of the entry of the input and the output is mismatched with the good simulation or good gate. Right? So C naught will be preserved. If I look at this E naught as a bad gate, the inputs are now 0 1 and the output is 0, which is same as set of input and output for the good gate simulation for the second step. Therefore, this fault will also be eliminated. B naught will be preserved because the input is 0 0 and the output is 0. So हमने क्या किया? Concurrent fault simulate करी. ये दोनों अब no more bad हैं. They are good simulation. So these are eliminated from my fault list. But now I will add some more bad simulated bad gates. Why will I add bad gates? Because A naught is no more a bad gate, but A if stuck at 1 should give me the error. Therefore, in the next step or in the second step, I will have addition of or updation of the fault list for this AND gate and the fault will be denoted as A stuck at 1. If A is stuck at 1, the input become 1 1 and the output also becomes 1. Other than that, E will also show us a stuck at fault at 1. If E is 1, the input remains the actual 0 1, but the output is 1. So these two faults are added in this step and these two faults are eliminated in this step. Similarly for OR gate. OR gate में अब inputs बन गया 0 0 और output भी है 0. So the set is 0 0 0. Now in this list for the OR gate, if there is any gate which has the input output as 0 0 0, that will no more be considered as bad gate. For example, this E naught. E naught में क्या है? 0 0 0. वही हमें actual good gate में के simulation में चाहिए. So this is no more a bad gate. Similarly, A naught will be eliminated because the inputs are 0 0, output is 0, and C naught will also be eliminated because of the same reason. Right? Now change ones to 0. यहाँ पे 1 goes to 0 changes to 0. So ये भी सब 1 0 बन जाएंगे previous वाली list से. There are 3 possibilities. Now check if I get again the same set 0 0 0. I get it for G naught. So this is no more a bad gate. So these 3 gates are left in this case. Right? Now what more to be added? Corresponding to these cutout gates, I will add some more stuck at fault. Agar E stuck at 0 is no more a fault, it means E stuck at 1 will be a fault. Because यहाँ पर E का value अभी 0 है. If E is stuck at 1, the inputs to the OR gate become 1 0 and the output will be 1. What is the other gate that will be added? Any idea? G पर change हुआ है, 1 से 0 हो गया है, so the fault list of G will change. So G naught हमने हटाया था because now the good value is 0, so the fault will be considered as G1. ठीक है, G1 पे क्या होगा? Input is 0 0, output is 1. The other inputs, go back to primary inputs now. E की fault हमने consider करी है E1. When will E be 1 at the output of this AND gate? We are considering this case when A equal to 0 है, B equal to 1 है. I want E to be equal to 1. So what will be the possible fault? A stuck at 1. Actual value is 0. If this value gets stuck at 1, the inputs to the AND gate become 1 1, so that the output at E becomes 1, which becomes the input to this OR gate. So the first input becomes 1. The other input remains 0, so the output is still 1. Right? F से हम propagation नहीं देखेंगे because there is no event on F, so we will not look into this wire. Only the wires and the gates at which the event occurs, I am considering those. So now my updated fault list consists of 6 faults: F1, E1, G1, B0, D0 and A1. ठीक है, ये क्यों डिटेक्ट होंगी? क्योंकि एक्चुअल आउटपुट तो 0 आना चाहिए था, बट इन सब केसेस में आउटपुट इज कमिंग आउट एज 1. It is different from the actual output. Therefore, test pattern 0 1 will be able to detect these faults where I have put a tick mark, a check mark. These 6 faults will be detected. ठीक है, so test vector 1 0 will detect F1, E1, G1, B0, D0 and A1. What will be the faults that will be detected by the first test vector 1 1? We look at the fault list of G. Wherever G ka value is changed, only those faults will be detected. So G ka actual value was 1, but in this red gate the output here is 0. So this was able to detect E stuck at 0. However, F stuck at 1 will not be detected by the first test pattern because G ka actual value is 1 and the faulty value is also coming out to be 1. So F1 will not be detected by the first test vector. G naught will be detected because G do not agree in the values. A naught will be detected because output of this and G equal to 1 do not agree. B naught will again be not detected because iska bhi output 1 hai aur actual output bhi 1 hai. So this will not be detected. But C naught will be detected since the outputs are different. So test pattern 1 1 will be able to detect 4 faults and test pattern 1 0 will be able to detect 6 faults. Okay? In the next pass, if an event occurs again on line A, then AND gate and OR gate will be analyzed. But if in the third case, the event occurs on the B part, if the event now occurs here, 1 goes to 0, it means I will have a change seen here. I will have a change seen here. Also, I will have a change seen at this NOT gate. So 0 goes to 1. So then all the lists will be updated. List of AND gate, list of NOT gate, list of OR gate. All the 3 lists will be updated. ठीक है, यहाँ पे output goes from 1 to 0. So ये again 1 to 0. ये 0 to 1. So here no change. Actual value no 0 था तो 0 के बाद 1 हो जाएगा. Fine. So now you will in the third pass you will update all the fault list for AND gate, NOT gate and OR gate. This is concurrent fault simulation. More details of the fault, but the number of lists that need to be maintained is small. Every time we simulate a good gate and the bad gates, in the next pass we eliminate those bad gates which are no more bad but they can be considered as good gates if the set of input and output agrees to the values of the good simulation. So we eliminate those faults and we add the new faults. फॉल्ट के टाइम ये ध्यान रखना है, सबसे पहले हम लोकल पिंस पर ध्यान देंगे, उसके बाद वी विल ट्राई टू मूव टुवर्ड्स प्राइमरी इनपुट्स that will contain that will make the entire list. Fine. Any problem? Just give it a try with the next two circuits that I'm going to give you, then it would be clear to you if you work with these circuits. The first circuit is simple, an AND gate and an OR gate. Three inputs A, B, C. 0, 0, 0 and 0, 0, 0 gives me the non-faulty circuit. Assume the test vector initially as 0, 0, 0 here. Find the fault list for the circuit. Then update the fault list for the test vector T2 as 1, 0, 0. It means you see an event at A. For this, try to find the updated fault list. Okay. A second complex circuit. Let us say this is G1. Then I have G2 and a NAND gate. G3. So that I have inputs A, B, C and D. Let this be E, F, G. Analyze for test vector T1 as 0, 1, 0, 1, followed by the second test vector T2, 1, 1, 0, 1 using concurrent fault simulation. Fine. Give it a try for both the circuits, then we'll discuss if you have any problem.
मैम लास्ट क्वेश्चन दिखाइएगा.
ये अच्छा इससे पहले वाला.
Yes, ma'am.
ठीक है. Now this is all about your 4 types of simulation. Discuss among yourself and give me a time for the quiz on your fault modeling and fault simulation by this Sunday. ठीक है दीक्षा. Diksha, you are not here. Anyone? Any other CR?
मैम संडे को ही रख लेते हैं।
Time?
टाइम मैम कन्वे कर देंगे आपको।
Okay. Fine. So you will have a quiz on Sunday. Time you will tell me on the topic fault simulation and fault modeling. That is all for today. We'll take one more lecture for this unit to complete. Half a lecture, then we'll start with the next unit. Okay, that is all for today. You may leave.
Thank you, ma'am.
Okay.